Hello there, team, and welcome to this update on our volcanic eruption in Iceland. Today is March 18th, Monday. It is about 1:30 p.m. here, Mountain Daylight Time, so that would make it around 7:30 p.m. over in Iceland. Just want to update you on the eruption that began Saturday, March 16th. Talk a little bit about what's happened since my last live stream yesterday on Sunday, and just get you updated with all the news and data that we have since then. So thanks again for joining me. Appreciate your support. Appreciate you jumping on here. Please make sure you like and subscribe with the channel so we can continue to promote good geology education and information. So the eruption that began around 8:30 p.m. on Saturday evening, it continues, as you can see here with the webcam, but the activity has diminished quite a bit, and we only have a short segment near the south end of the fissure system that remains active. So the volcanic activity appears to be waning, and this is typical of these fissure systems. They get concentrated into just a few vents. As these vents start to just spatter out this increasingly sticky lava, that builds up cones, or what we sometimes call spatter ramparts, around the length of the fissure. You can see from these spattering vents that there are lava flows that are emanating out and flowing downhill to the south, but they're moving quite slowly. So in terms of the overall volume and the high temperature of the lava compared to what we saw on Saturday, and also the height of the fountaining, you can see that this system is definitely in its last few gasps. It might last another 12, possibly 24 hours, but I would be really surprised if, 24 or so hours from now, this thing had this level of vigor and activity. But we'll see moving forward how things look. Let's go ahead and look at some of the data. My much anticipated, well, let's look at a couple webcams here first. So a couple other views from of the area, so you can see which sort of region and area is actually still erupting. You can see again that's just a short segment here along the fissure system that's still actively erupting. It's still producing gases. Pretty clear day now. It was stormier and rainier earlier in the day. Let's go to the Met Office, and I think actually what I want to start with, rather than going through the update, is let's get to the, for me at least, much anticipated flow field map. This was something I've been waiting for all weekend, and the Met Office finally put this out. I think it's estimated. It doesn't have maybe the level of detail they might put in a future update, but this is good enough for me because it nicely shows where this lava field sits with respect to the prior eruptions in December, January, and also in February. So just to orient you, here we have the town of Grindavik. These sort of thick red lines surrounding the town are some of the defensive barriers, the berms, if you will, that have been erected to guide and help direct the lava flows away from the town. There's another set of such barriers around the Blue Lagoon and the power plant area. And what we can see here, let's maybe make this a little bit bigger. I don't want to click that because it'll maybe make it a little bit too big. There we go. So let's start at the north end here. So they did not pull out the fissure, the vents on here, but they stretch roughly from, right, I'd say about here up towards Stora Stogafell. So this area here is where the fissure systems were erupting the lava. And then in this orange color here, you can see the extent of the flow field. Now this flow field, this orange color here is the extent of the flow field at a certain time, I guess around 1:55 yesterday. And then the red updates it to about 3 p.m. or so later that day. So two different sort of time frames there. But most of the lava erupted early in the eruption, and you can see that shown here. So what's interesting to me, and then below this orange color, you can see in gray the December 18th eruption, and in pink or purple, this color here, this is from the February 8th eruption, and down here, that's our January eruptive flow field. What's interesting here and worth noting is that the vents that opened up on Saturday occupied essentially the same vents and fracture systems that were the conduits for the magma on December 18th and then again on February 8th. So it seemed quite clear that for the most part, this system has preferentially established a good pathway, a a good fracture network system to move that magma from this zone here where it resides about 5 kilometers down over here to the east, and then it erupts through this system here. And so I think that's important, and we'll probably circle back to that point as we move on with our update here. But a couple things of interest here. So when this eruption took place, and we had these fissure vents and fire fountaining taking place. It was quite vigorous initially. That lava came out with a lot of gas. It was very hot, and so it flowed further away. And it primarily formed 3-channel paths or lava flows from the vent area. So there was this pathway here that took off to the west, ended up flowing over the top of the road here, the road that connects Grindavik to the Keflavik and the Reykjavik area to the north. But it did not progress all the way to the pipeline here. So let's zoom in a little bit on this area and stick with this area at first. So here's the pipeline that supplies hot water and cold water to most of the peninsula region. So that's an important piece of infrastructure. Since the February 8th flow and event, they have buried this pipeline. If you remember back in the February 8th event, this pipeline was damaged, actually severed for a number of days. People were without heat and hot water in their homes for a number of days until that could be restored. But since then, that pipeline's been buried underneath compacted rock and soil. And so the hope was that if the lava flowed over it again, that it would be deep enough and insulated enough that that lava wouldn't impact it. As it turned out with this last event, that wasn't quite put to the test because the lava flow ended just short, within a few hundred meters or so of that pipeline. So the good news here is while the road was covered, and that was probably to be expected, there was no damage to any other infrastructure. No lava actually was ponded or was pushed up against the defensive berm, and none of it actually came over the pipeline, which is now buried. What was interesting here in looking at this map, though, is if you were with me during the eruption on Saturday, I had wondered, and that live stream went on for 4.5 hours, I had wondered aloud if there's a bit of the purple February 8th flow, it kind of comes down right to here. And so it was a bit of a choke point there. And what I didn't know was if the February 8th lava flow had built up enough verticality to it, if it was a significant enough topographic feature as a flow that it was going to steer this March 16th flow and take it through this constriction point between the defensive berm and the lava flow. And we can see now what the end result was. That February 8th flow apparently was a very thin, probably fairly low viscosity, very fluid flow. So it did not inflate. It did not have a very large vertical profile. And that the flow on Saturday basically flowed right over the top of it. Now with each successive flow, you're changing the topography. So we might not expect the same thing to happen with a future event. But in other words, it really didn't come to the point where it might need to be pushed up against the defensive berm. I was worried that in going through that constriction, the lava might inflate and build up and possibly overtop the defensive barrier, but that was not the case, so that's good news. And then you can see how far it progressed later, at least the last time the run was made. This lava flow, this northern flow that extends to the west, has completely stalled and stopped, so that one is no longer an issue. The second significant flow was this one down here to the southeast from the vent system. We can see two branches of the flows kind of wrapping around this symmetrical shield volcano here. So this is an older shield volcano, and we had flows moving along its eastern margin. And this flow never was an issue because it's a dead end. It's going to run into these higher, steeper hills over here. It was going to pond in this valley. So even had a lot of the lava been directed into this pathway, it really would have not posed any sort of threat to the infrastructure. There's just no way to get enough lava here for it to pour over these steep slopes and down onto the roadway here. It would take a lot, is what I'm saying. It would take a significant amount of lava to get it out of this little embayment in the topography here. And then the third one, the more I guess, critical one that became apparent as the day went on was this southern flow. The southern vents are still active, and so they've been active the longest and maybe the most vigorous. And so they produced a pretty healthy lava flow that came down to the south, and it impinged upon the boundary between these two segments of the defensive berm or barrier. And a little bit flowed to the west, but because this January flow had built up so much ground, that wasn't a pathway for it to take. And instead, it turned and flowed right along that defensive barrier. And then you can see as the furthest extent it made, at least as of yesterday, March 17th, around 3 o'clock in the afternoon. Since that time, it's moved a little bit, but it's still a good 300 or so meters away from the road. And we'll look at that with some of the updates here. So the good news and the big takeaway here from this eruption is that while we had a fairly strong and significant eruption when compared to the last few eruptions in this region, that no critical infrastructure was compromised or lost other than the roadway right here. That was the only thing that was impacted. And furthermore, as we can see down here near Grindavik, these defensive berms and barriers did a wonderful job of deflecting and redirecting this flow off to the southeast. Had these structures not been in place, I think you can see how this lava flow would have extended downhill following the topography and impacted and certainly destroyed some of the structures here on the eastern side of town, and possibly even made it to the roadway. I think I fully think that unimpeded, this lava flow would have crossed at some point the southern road, and heaven forbid it would have made its way actually into the harbor down here. So great news there in terms of good planning and mitigation structures and proving their effectiveness, at least for these first couple of runs here. So super happy that they finally got the flow field map up. And this, of course, is on the Met Office site, and I'll be sure to put a link in the video description if you want to check this out for yourself. So let's go to the Met Office update here. And they have updated a few things for today, March 18th. Basically, they state here that the activity is quite stable, and it's very slow movement of that lava tongue to the south heading towards that coastal road there. They did update the hazard map, but I won't spend much time on that because that's some things we already know. Actually, it's actually not a bad idea to pull it up because I just noticed that it does show. They did put let's see if we can get this in the frame here. They did put the new lava field on here in gray, and they do have the vents on there as well. So now you can actually see that the vents extend from just near the southeast end of Stora Stogafeld, this hill here, and they trend to the southwest. There's a little bit of an elbow here, and then they're just northeast of Hagafelt and this shield volcano here, Mithait. I believe that's how you might pronounce that. So there's the hazard map. And so there's a couple other updates that came through since I have been with you yesterday on Sunday. One is, here's another one that shows, this one shows the vents as well. So you can see the vents here and the extent of these flows. Again, the dead end flow, not an issue. Right now, because this one is the only one, because these southern fissures are still the most active, this is the only one that's being fed by lava. But as I'll show you here in a second, the lava at this end is very slow. It's sluggish. It has transitioned from a hot fluid, pahoy-hoy, ropey surface flow because it has traveled so far from the vent and has rolled over itself. It's not only cooled off quite a bit, but there's a lot of shear stress that's tearing up the lava. And so it's transitioned into what we call an lava flow, a lava flow that has a steeper front to it, but is characterized by just black rubbly rocks falling off the front of the lava and less fluidized, low viscosity type of behavior. So we do have a couple nice maps there from the Met Office, and I think they were it was tricky probably over the weekend because they were maybe short-staffed because it was the weekend, and also the weather was really lousy for getting those maps out there. But a couple things here this morning, that would be today. It was about 330 meters from the edge of the lava flow down to the road, and we'll talk more about that here in a bit. The area of the lava is estimated at 5.85 square kilometers, so the entire area. based on a satellite image yesterday. And they'll probably get better measurements going forward as the day advances. This is an interesting map here. Let's see if we can get this a little clearer. This shows as of today, March 18th, at around, I guess, noon-ish time, the volcanic plume. So the winds were coming out of the southeast, and that was carrying some of these volcanic gases just to the south of Keflavik in the airport. And so there could be some variability there. Wouldn't doubt that there could be higher concentrations in this area. But the good news is in Iceland, I mean, the wind's just kind of always blowing. And so it's probably not a big health hazard for the most part, although, you probably wouldn't spend too much of a time in that zone. But likely the winds have shifted, and so it's not one specific area that's being inundated with these volcanic gases over time. And then I wanted to get to this map here, which is pretty interesting. This is from yesterday evening, around 6:30 in the evening. And it focused on, at that point, that lava flow on the south end was creeping forward. And there was some concern, which I think has since largely abated. I don't think we're expecting that lava flow to either reach the road, the coastal road, or even the coastline, the ocean itself. But they did put together some modeling estimates in terms of if it did get down to the sea, sort of the area that might be affected, because it would become a little bit more explosive, fragmenting that lava into ash and larger particles that would get thrown out because you have the water in the ocean expanding into gas, so it becomes a much more energetic type of eruption. And so they have a radius here. This doesn't factor in the wind. The wind could change this into more of an ellipse. But basically the area where it would be hazardous, and you'd have tephra, ash, and maybe even larger particles potentially falling out of the sky. But luckily it hasn't gone to that scenario. That has not played out so far. And at that point, it was moving at about 12 meters per hour. I know it's slowed down considerably since then, but yesterday that was a bit of a concern as to how quickly that might progress. So nice little view there of the current eruption as it stands, but it's definitely winding down. So let's look at some other data here. So we've looked at the flow field map. Let's look at earthquakes briefly. I guess I've got two windows of earthquakes opened up. And let's look at the Reykjanes first, and then I'll take you to another part of Iceland. So earthquakes, as you might expect, following an eruption, well, an eruption that's still going on. There's been basically no earthquakes. I guess we have one over here near Thorbjörn. That was magnitude 1. That was about 3:30 this afternoon. Kind of shallow, but again, not alarming. Just absolutely no earthquakes, and that's a 24-hour period. If we select down to 4 or 5 hours, we just get that one earthquake there. So very little seismic activity, but again, that's to be expected in the hours after an eruption. Once that conduit is established and the lava is flowing through the system, we're not actively breaking rock, we're not forcing fractures to become wider, and so that reduces the seismic activity. But there was in Iceland a more significant earthquake over here in the central part of the country, along the north end of the Vatnajökull glacier. This is the biggest ice cap in all of Europe. And there was a 4.4 earthquake early today, or just a little bit after midnight. But look at the depth there, almost 8 kilometers in depth. Now there was other quakes associated with that. So the red ones here are shallower. So this was a 3 a.m. quake that was pretty shallow. And then there's one there that's a 2.3 that's pretty shallow that occurred just after that. But most of these are fairly deep, 5 kilometers there. What's this one here? Another 8-kilometer one. Oh, that was the big one, sorry. There's the one that's 6 kilometers, 3, so on and so forth. And so I guess my conclusion here is my analysis of this would be that it was probably non-volcanic. It definitely is not indicative of an eruption. So while this is the Barðabunga volcano and it has erupted in the past, I think most recently in, I believe, 2014, nothing I'm seeing here is suggestive of magma on its way up and fueling an eruption underneath the ice cap. We just don't have the clustering of quakes you'd expect to see. The one big quake was pretty deep, so about 8 kilometers down. Lights turn back on. Oh no, the lights are off. There we go. Lights are back on. And yeah, I don't like see anything here that's alarming. These big earthquakes happen from time to time in these central volcanoes in the interior of the country. So interesting chain of events. Probably too remote that it was really felt by a lot of people because it's in a very isolated part of the country. But a pretty deep earthquake, possibly tectonic in origin, and if it was magmatic in origin, it's definitely, I don't think, indicative of magma that's ascending up towards the surface and potentially going to trigger an eruption. A lot of folks have been interested in seeing what the GPS signal is now that we're, a day or two past the main eruptive activity. So if we go to our Svartsengi station, which is the closest one, we believe, to more or less the central portion of this shallow magma body. We can see the uplift through December and January following the December 18th eruption. The January 14th was an odd event because it didn't show significant uplift at this location, but we did see it on the February 8th eruption, which is here. And then you can see the last little cluster of data points here from the from this March 16th eruption. And too few data points, I think, to get too excited about anything. 5 data points with those error bars. I'm not ready to put a trend to those at all because of the size of the error bars there. So hard to say for sure, but all we can say is we had the eruption that caused the ground to move down to lower. And so that's what we call deflation. And what we might expect to see in the days and weeks to come is this thing starting to pick up and steadily increase in elevation. That would be what we call inflation, largely mimicking this trend we've seen here over the past few weeks leading up to Saturday's eruption. So there's our Svartsengi station, the Blue Lagoon station. Again, these all show very similar trends. Deflation after the eruption as more magma left the system and erupted to the surface. Steady inflation more or less, and then Saturday's eruption. And this one does show a little bit more of an uptick. But again, I'm not ready to start to project anything from 5 data points with the error bars such as they are. So likely that we see this thing start to resume inflation over the coming days and weeks. That's what we'd expect to see, and that would indicate that this system is being fed by a deeper source of magma at a fairly constant and steady rate. I think all the other stations show the same trends, so I'm not going to belabor that point much further. Couple of news features. So this one just really had some nice pictures, and thanks again to Amanda Joe for sending me a lot of the links and a lot of the information you're getting to see here. And so some nice pictures of the eruption. These are all just different little news points here. There's the road. Oh, this is from the top of the berm. Yeah, and you can see some of the lava here over here in the distance. This gives you some perspective of how tall these defensive berms are. I know there's not a lot of scale there, but we have a little, meter tall traffic cone here. And I'm told these are around, 8 or so meters tall. So this is what these defensive barriers or berms look like sort of at ground level. And then again, this news agency just kind of goes over some of the same things we have there. This one gives you a little bit of perspective of the front edge of that lava flow. So this is that lava flow down at the south end. So this is this lava flow right here that's very close to the road. And this gives you a little bit of perspective of how tall that is. So it's probably a good maybe 5-6 meters in height, and just a classic what we call an lava flow front, where it's very jagged and spiny and rubbly. Lava flows are some of the most irregular. You'd never, hiking across this thing is just a bad idea. You're going to fall, you're going to cut yourself, you're going to twist an ankle, just nasty stuff. But you can see the incandescent glow, and these are the very slow lava. So this thing is advancing literally at a crawl, if you will. It's easy to just stand in front of it. And then when it slowly advances forward, you take a giant step back, you enjoy it a little bit longer, take a giant step back. So this person's not at all in any sort of danger there. But classic view of that of that flow front. And this article just talks about it being around 300 or so meters from the coastal road there. And this article was interesting because what they've been able to do to measure the speed of this lava flow front advancing is they just put a stake in the ground and measure the time it takes for it to go for work from one place to the next. So they're literally using just some very simple methods to estimate the rate at which the front of this lava flow is advancing across the landscape. They literally talk in this article about just putting stakes in the ground and then timing, measuring the distance from the front of the lava to the stake, and then measuring the amount of time it takes for it to advance that far. And then finally, and according to Amanda Jo, let me quickly pull up on this other screen here the thing she sent me about this particular news item. She says that this bit of news apparently was not sitting well with some of the locals. Let's see if I can find it here. It's not in that one. But basically, this talks about, oh, here we go. No residents or businesses in Grindavik today. So they are not allowing the fishing activity to take place. I think they're concerned with the air quality with some of the gases being that close to town. But apparently there's some people, she's just hearing through the grapevine, that are not happy that at least the businesses could not operate today. So interesting. So I think that's all I have for today's update. Kind of brief, but I wanted to get one more in before I leave on my vacation here early Wednesday morning. So I'll keep monitoring this, of course. I think the big takeaways here, at least for me, is one, I expect this to wind down. I don't expect that this activity will increase. This should continue to the lava output should continue to abate and get less and less going into the next few hours, and maybe by tomorrow at this time, there could just be one or two red little glows and maybe a few little spitting spatter cones in the whole system. It's definitely dropped a lot from yesterday and even more so from Saturday. I think it's interesting in looking at the map that the same fissure system has been now used 3 times. So there's clearly a well-defined pathway that has fed 3 of these eruptions over the past 4 months. The January 15th one was a bit of an anomaly. It lies along the same trend. And I don't have a good explanation for why the eruption was further down the rift system or the fissure system at that time rather than up here. But pretty interesting that this pathway has been established. I would expect that any future eruptions would take place here. And when are we going to see the next eruption if we do see one? I would guess, kind of based on the GPS data and the output of this one, and we still don't have I haven't seen a measurement for total volume yet, although that may be coming out soon. I've heard some estimates from some other people, but I'd like to hear it probably from the Met office before I discuss it. But maybe another 5 to 6 weeks before the whole system is recharged and primed and ready to produce another event. Will it occur in the same place? That would be the most likely scenario because we've seen 3 out of 4 events in that area. We'll have to, of course, monitor the earthquakes and see if the earthquake or the ground deformation data leads us to believe that the eruption could take place elsewhere. But all things being equal, I would expect a similar eruption location, similar volume and duration perhaps to this one or the last few. And then the interesting thing will be to see how the next eruption and lava flow interacts with these previous lava flows and how it dictates where it might flow. Are we going to get another flow off the north end that maybe it does go through that constriction this time because this is built up a little higher, or maybe this is still the low point and the lava just flows over the top of the February and March flows as well. So I guess I would start to look for something. We'll of course keep tracking things as we go, but definitely by mid-April, going into late April, I would start to be looking at other looking at the data to see how things might be progressing moving forward. So hopefully that was helpful. I wanted to make this a fairly brief update for today. Got a lot of packing and prep work to do for our trip. I appreciate everyone for joining me. Thank you for your support, for watching the channel, for sharing, subscribing. We're slowly but surely growing this great geologic community, and I'm happy to be part of that with you. Happy to be learning about this volcano and other topics as well as we progress together. So we'll see you soon. If anything significant happens, I will be sure to jump on my laptop and put together the best update I'm able to. So thanks again and have a good day.